does a harmonic mitigating transformer eliminate all of my harmonics? So let's answer that question. Does a harmonic mitigating transformer eliminate all of your harmonics? And the answer is no, but you can use transformers to work together to minimize the harmonics on a power system. So there's a lot of different ways to look at it. And the first way we've talked about in the past is with the phase shifting transformers and the harmonic mitigating zigzag transformers. So let's take a look at that. So if we look at a zigzag transformer, we're going to basically not eliminate, but recirculate the third harmonic currents back to the neutral. And the way that works, and we have this in several other videos, is that we actually get cancellation on the leg of the core with, for example, A and C, B and A, and C and B. And then what happens is it doesn't circulate in the delta like a normal delta Y transformer. But at the end of the day, third harmonics are going back to the load, fifth and seventh are coming through the transformer. So then how do we handle fifth and seventh harmonics? Fifth and seventh, just like with VFDs, because these are 6-pulse drives, we could take, fundamental fifth, seventh, 11th, 13th, the fifth and seventh from this side, cancel with the fifth and seventh from this side. So this could be a delta-delta, or could be a delta-zigzag harmonic mitigating transformer paired up with a delta-Y. And essentially you end up with 2 6-pulse drives creating a 12-pulse system. And essentially if you think about what's going on here with this wave shape, that would be exactly the same as what we saw in the previous example once you eliminate the third harmonics. Okay? And then if you look at all the different parts of that spectrum, we have the fundamental, which of course is doing the work, and we're not going to eliminate that. We could get rid of the thirds or recirculate the thirds back to the loads. We could do that with a delta Y or a delta zigzag. Again, the benefit of the delta zigzag is you don't get the heating losses in the primary winding. Fifth and seventh can be eliminated or minimized with phase shifting by taking combinations of transformers. And you can even do that with the 11th and 13th, 17th and 19th. So you can make 6-pulse systems go into 12-pulse, 18 pulse, 24 pulse. But as an example, let's say you had a commercial building and you had a bunch of computer power supplies on each floor. We'll say we have 5 classrooms, 4 classrooms, and 3 classrooms of students with computers. So if you had delta Y transformers, you add up to a total of 12 units of that fifth and seventh harmonic current. Remember, the third harmonic is going to circulate in the delta, go back to the load. So we don't worry about the third on the primary of these transformers. But on the primary, on this riser bus, we do have to worry about the fifth and seventh. If we phase shifted just one with a harmonic mitigating transformer, we'd have 5 plus 4 minus 3, or 6 units of harmonic current for fifth and seventh. So basically, I've cut my harmonic current in half. And then if I strategically pick the right one, minus 5 plus 4 plus 3, I could go down to 2. So picking the right phase shifting transformer and actually combining those transformers to do harmonic mitigation by cancellation is the way that you get harmonic mitigating transformers to work for you to eliminate harmonics. So again, third harmonics don't come through the primary of the transformer. They circulate and go back to the load from the zigzag winding, or in a delta Y, they go from the delta winding to the load. The fifth and seventh, with strategic combinations, you can cancel the fifth and seventh from 2 different systems. And again, you could do 18 pulse or 24 pulse or even higher if you wanted to cancel harmonics. So harmonic mitigating transformers can be used strategically throughout a system like that to really reduce the harmonics that you see. And then you don't need harmonic filters or other things added on after the fact.